Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z, and we have another bit of a short one this week. A bit of a slow week on topics, but we have a few things to talk about.
Yeah, I mean, there's some good topics this week at least, I'm still happy with it. It is very much a Google special, though.
Yeah, and we'll jump right into that. So our first topic here is about hacking Google AI for $50,000, and it tells a really nice story about how these developers collaborated and got hacking on Google's AI, which I just
Well, I
love those
think
sorts of
these
stories.
are bug bounty hunters, not necessarily developers. So they
Oh,
talk
sorry,
to
did I
some of
say
the
developers?
developers. Yeah,
Yeah, sorry, I meant bug bounty researchers. Yeah.
yeah, like I think they had
Um,
access to researchers during some of the hacking events, but themselves, like
yeah.
I know
So
they're no, I recognize the name just as bug bounty hunters.
yeah, so that's actually what I was going to get into, which is probably why I got it a bit confused. So it started with a Google event in Vegas where a researcher reached out and was like, "Hey, do you want to hack on Google's new AI features?" And during DEF CON, Google reserved a suite, and Google engineers were there as well as the bug bounty hunters, which was a really awesome opportunity as they were able to, ask questions and basically get them to check the source code to dig into stuff or tell them if their assumptions were valid. So, very nice opportunity for the researchers there. And they found multiple vulnerabilities over the course of that event. They also detail one that was found before. So, before the event, ResZero did have an IDOR in Bard, which is detailed here. And that was basically just the fact that Bard had a vision functionality that would take images, process them, and then describe them. But the problem was by just swapping the path and the request body for the image path to process, you could have it describe someone else's image. So, pretty straightforward issue, but could be pretty impactful, especially if that image contained text or something like that. It could be
Yeah,
pretty significant.
I mean, the fundamental issue there feels like just the fact that you could have two different users, and of course, one user is going to have permission to access some file, another user isn't going to have that permission. But Bard, because of how it works, may have permission, and in this case, did have permission to access both files. Or kind of what matters, the fact that they could access the other user's file, like you wouldn't.
Yeah, it
And
has like
it's
a
kind of
super user access. Yeah.
yeah, like the fact they just have a more privileged access, and then you're kind of tricking the LLM into using its access for your benefit.
Yeah, which is how a lot of the LLM bugs work, but they're cool. It's something different from your typical attack classes.
I
So,
mean, I feel like we've seen that a couple times, but I mean, a lot of the LLM bugs are. I don't think necessarily abuse that because that isn't. I guess it is a more common feature now and is becoming more common, but a lot of LLMs also don't really have that access, don't have something too special. I mean, you might be able to leak training data or private information that like is specific on it, but there's less of these. Like Bard is one of the first that are kind of acting as this agent and can access your data in a sense.
yeah, I was speaking of like tricking into leaking privileged data in general, not
Oh,
necessarily
okay.
another user, but that's a fair point too. Bard is kind of in a unique position, which is part of why they really wanted to attack it here. So there was that IDOR. The path does seem fairly randomized, so I'm not sure how practical that actually would be, but it was
Yeah,
still
that's.
valid.
I was kind of talking about that sort of issue with someone earlier in the week, or I guess last week now. But on one hand, it kind of comes down to that question of if you have an IDOR, but the ID that you end up like figuring out is a universally unique ID, it's a UUID. Is it still an issue? Because you shouldn't be able to prove, and we're just going to assume like it's sufficiently random and all of that. There are whatever things that can go wrong, but in that case, if it's just that ID that is protecting it does have randomness, it's probably as random as many tokens would be for trying to limit access anyhow. Is it a security issue? I would argue on the side of yes, it's still an issue because the IDOR is still there, even if the information leak for that ID is not. Um, with a bug bounty, you usually want to be able to prove exploitability, so you want to show them that hey, I can leak the ID in this way. Google doesn't always expect that, or didn't in this case, but some companies will kind of reject these sorts of reports if you can't show them how they leak it. Kind of taking the idea of you can't brute force this, so there's no way you're getting this, realistically, like these sort of IDs can be leaked in a lot of different ways. Either just like some JSON thing gives you, like you end up getting access to like API information. They can be logged in a lot of different locations that may be leakable. Refer headers can sometimes leak this sort of information too. There's just so many places that IDs in the URL can be leaked that it doesn't feel like a good idea to also kind of rely on them as a security mechanism. And
Yeah, so
so
I mean, that's the thing. Like when you focus on the pure brute force angle, when you have as many characters as are here, like in the path they put here, I'm not going to count them out. But when you have that to the power of 34 or whatever, like yeah, it's not a reasonable search space. So it's kind of comparable to like trying to brute force like AES keys or tokens or something like you're saying. But the difference there is tokens and keys are known to be secret. Like when they're leaked, they are considered compromised. So where these IDs you wouldn't typically consider secret, like yeah, I would still consider it a security issue, even if it's not a super impactful one or not like a rushed, it's gonna be devastating kind of issue. Like it's probably not, but it's still an issue.
yeah, and the other thing is tokens and stuff are easily rotated. Like oftentimes, even every time you log in, you might have new tokens for everything. They can easily be expired and all of that, whereas the ID is generally more permanent. So
That's
I
a good
just
point
don't like
too. Yeah.
relying on it as a security mechanism. Some companies do, so like not everybody's going to be able to report this type of bug. I mean, this one with Bard, because like the average user wouldn't pass the permission checks, I believe, to actually access the files. You do have the other aspect, but in terms of the IDOR itself, personally, I'd argue the IDOR is still there, and it's just like in memory corruption, we'll often find bugs that allow like uh code execution, or sorry, would allow like control flow hijacking, but you take advantage of it without information disclosure. You need like two bugs, or you can turn one bug into like two primitives, but you need something more than just that bug, but it's still a bug on its own. That's kind of what I think about with IDORs here too.
That's a fair analogy, I think. Yeah. So that IDOR was acted as like an inspiration. So then they got into the event. So the first bug they found in the event was found in the Google Cloud Console, which also had some new AI features. And they discovered there was a GraphQL endpoint, which seemed like an interesting place to target. We talk about it quite a bit on the podcast. Though the request bodies to this endpoint were signed, and they were signed with hard coded keys. So it was a bit of a weird thing that we're like, okay, if we can't control the contents or whatever, is it still, can we do anything with this basically? Something interesting to notice though that was that the signatures themselves were not signed. So they could add multiple signatures in, and they thought that by doing so, they could get each signature directive executed and basically exhaust the server from responding to other requests, which, after getting authorization from Google, they were able to confirm. With a million directives or a million signatures, they could cause more than a minute of hang time on the back end, which gave them $1,000 with a $5,000 bonus for coolest bug of the event, which, by the way, that's a pretty neat bonus to offer. I do like that incentive.
Yeah, from Google, like I generally like their bug bounty program. Like they do take the issues seriously.
They're very
And
generous generally, yeah,
yeah,
and
and
that'll
kind
be
of
shown more and more throughout this blog post.
I was actually just kind of going to hijack it and jump into that next bug to kind of comment back on this. But with the next bug, they basically just asked the question like, hey, can you check how the signatures for the requests are signed? Or, just looking into that and, how can we if they can forge a signature? They look into it, and what they realize is, oh, it's a hard coded key in source code, and it's not very random. It's just a sentence that wasn't too random at all, but probably couldn't be guessed or brute force. Despite that, they had a bit of a debate, the engineers there did, and they still gave him $1,000 bounty, which is something that Google's bug bounty tends to do, is not necessarily pay out because you asked the right question, but when you send them a bug, they will also kind of triage it and figure out what the maximum damage you could have done with the bug was. So even if you didn't figure out how to exploit it, they'll look at it and be like, this could have hit the X, Y, or Z or done whatever, and can increase your bounty on that basis, even if you didn't figure it out, just on the basis of you reporting that bug. So just a really nice thing that they do that I think a lot of companies would kind of shy away from giving extra money because it was a more serious bug than somebody thought it was.
Yeah, they're very fair. They're not looking to like cheap you out of reports.
In general, yeah. I mean, there have definitely been some complaints about it, but there's usually more going on with
Yeah,
that.
sorry, I'm speaking generally.
Yeah,
Yeah, I don't want to speak for every case, obviously.
of course.
I
But
will say too, there was a bit of a fun thing there because so there was the hard coded key to sign the queries, and the Google engineers ended up trolling the researchers because like the researchers asked what the key was and they wouldn't tell them. But then afterwards, it was found out that they were actually saying the sentence used for the key out loud while talking to each other, and were like joking about that. So like the researchers had heard what the key was, they just didn't know it, but that was kind of a
yeah,
fun aspect to it. Not super relevant for the issue, but yeah.
no, but I mean, it also just kind of shows the, I guess, humor of the group. I mean, that's just for them, but still. But yeah, coming back around actually the signature bug, that's definitely an interesting bug class that I'm not sure if I've seen that before. Now, I don't think I've ever seen anybody really doing any bugs with the signature directive, so that could just be on me not being familiar in the area. But it does stand out as an interesting area to get like a denial of service from. Just something to keep in mind. Like I said,
For sure.
I haven't seen it. That definitely doesn't mean it hasn't been documented because I haven't done a ton when it comes to GraphQL and especially like hacking on the GraphQL API. So could just very much be my limited exposure to it and not something novel in this post, but it was something new that I learned out of this post at least.
And the final issue that they detail was after the Vegas event and had to do with Google releasing support for Bard with workspaces. So, as Z kind of mentioned earlier, Bard is kind of in a unique position. And after this, it was in even more of a nice position from an attacker standpoint because now it could have access to Gmail, Docs, Drive, etc. There's a lot more interesting information that could be pulled. So, when digging into it, one of the things they quickly noticed was that they were able to get Bard to render Markdown in its responses. Specifically, they can inject content into Markdown, say like a malicious link, and ask it, hey, summarize this thing and put it in let's say, a parameter query into a link, right? And then link to an image to get a request sent. So they got thinking, like, yeah, maybe we could summarize sensitive emails or something like that and get an X filter an image. They found, though, that when they tried it, nothing would happen because there was a content security policy in place, but they were able to find a CSP bypass, and that was because their CSP was fairly permissive in basically allowing all of Google subdomains for loading images, including the Google user content subdomain, which is notable because via Google Cloud, you basically can get arbitrary images on that subdomain as an attacker. So it was just a little bit too permissive of a CSP because of how widespread Google is. Now, even after that, though, they couldn't immediately get it to work because Bard itself seemed to find passing the googleusercontent.com domain into a message as suspicious, and it would refuse to comply with the prompt. But they were able to get around that by abusing another trick. And I don't remember this one. Maybe we've seen it before, but it's just skipped my mind. But when you pass in the AMP path into google.com, you can basically get it to redirect to another like Google domain. So by passing the Google user content URL with AMP, redirecting it, you could trick Bard into accepting the prompt. That yielded a $20,000 bounty and another $1,000 bonus for third coolest bug of the event.
Yeah,
So
so I will say it's AMP isn't exactly redirecting it. The way AMP will work is AMP, I forget what it actually stands for, but it's used with like news sites, especially to make like a mobile friendly sites. You know, when you sometimes click on a link on Google, which I mean, at least it used to happen. It has, I use another search engine now, but you'd click on a link and it would sometimes bring you into like this almost a new little UI, not like opening up a new app, still kind of inside of your browser on phones, but it would show you this alternative UI of the page, and you would actually be sitting on a Google AMP page. It's because AMP would kind of like proxy and expect the resultant page to be written using this subset of HTML and kind of written in this way that's supposed to be fast and enhance a user's web experience. Because it stands for Accelerated Mobile Pages. And it's like this HTML framework to make fast pages. So then they'll like proxy and cache those pages. So when they end up making this sort of request through, they're then able to kind of get the response come back. Well, they'll end up getting the whole hit. They'll have like Google make the whole hit over and all that. But like, yeah, it's proxying and not so much redirecting is my main point. It's not actually ending up on that page, but the requests will still be made to that page. Although they did have to use some URL encoding to get that too. Um, just including, so for those of you who are watching, you kind of see here where they've got the AMP URL that they used. And then they also had to include a little bit of URL encoding, just since it's part of the path here, they can actually obfuscate the Google user content.com domain from being used. So they can't just look for that in the string. And they've got the URL encoding, so obfuscates it a bit. And so they're able to get passed through. And then yeah, AMP just works a little bit differently. Definitely useful to know about though, in terms of some gadget potential.
Some really cool bugs there, and high paying bounties from all of them. So, and like
Yeah,
I said,
definitely
a
good
great
bounty
opportunity
set.
for the researchers to like get the insight from the developers. Like that's something that you're often not afforded doing regular bug bounty research. So
Yeah,
yeah,
that is something that HackerOne I know, like they'll do the live hacking events. I know a lot of the other programs are kind of getting in on that or on that train too of having more of a connection between some bug bounty hunters and the actual engineering team of some product because that sort of interaction can really help. Like what goes on here where they're talking about being able to just ask a developer about that. When I worked as a consultant, like that was generally my experience. Like I could go and just like ask, hey, like how do you handle this? Like if I come find it in code, if they gave code, even sometimes they did, sometimes they didn't, but I'd be able to just raise those questions. And while it doesn't like you show off your hacker cred by doing like everything all black box and stuff, it really makes the whole process a lot more efficient because you have somebody who's knowledgeable about the code, somebody who's knowledgeable about security. You merge that information and you're just able to find bugs and find good bugs a lot more quickly than if you had to figure it all yourself.
yeah, it's a tide raises all ships sort of scenario. Everybody benefits. So
Yeah.
it's a really good thing. Yeah. But yeah, if you're interested in the LLM stuff, as he said, I think LLMs are becoming more and more entwined with services that deal with user data. So I think these kinds of issues are something to keep in mind if you're looking to do LLM research. And like I said, even outside of that, it's just a really cool story. I thoroughly enjoyed reading this post.
Yeah, it's some solid bugs. Some really good finds here.
Yeah. So with that out of the way, we'll get into our next topic, which was a post by GitHub Security Lab on a SAML auth bypass, and a fairly straightforward one. Z, you were commenting on this one a bit on your prep stream. I was around a bit for this time, and you were saying about how SAML just makes it kind of easy to have these kinds of stupid issues, and you hated seeing it. So
Well,
I'll let you elaborate on that.
SAML is just overly complicated. Kind of tries to let you do anything and works with anything, and it's XML, and nobody likes XML, so there's that too. But yeah, the bug here comes down kind of to the usage of the XML sec1 command line tool. Uh, the high level issue is actually let me pull up the men page really quickly for XML sec1. One thing you can do with this tool, so this is how they would verify the signature of the SAML assertions that came back. So those are going to be saying like who the user is, all that, along with like being signed by a particular key, so they know it's legitimate. They have this verify function, and you can kind of see it generate things here. Saying, yeah, we want to do the verify. Passes in a public key. That's what should be used to actually sign the assertions. They have like the ID attribute, but that's unrelated to this. And you would kind of think, okay, you're passing in these commands, like you're saying, use this public key, from this PEM file. They also have one here for like dir, so you can kind of pass it whatever you need, but like that should be what's used to sign this file. Turns out that is not, in fact, what happens. And what XMLSec will do is, sure, if there's no other key provided, it will use like the public key that you provided in the command line. However, if this SAML that came in included its own public key and signed it using that public key and just encoded a public key into the XML it sent back, you could just tell, like, yeah, it was signed with this key right here, and here's the key. So you could basically sign your own SAML assertions, basically defeating the entire purpose of checking it signed because it would just use the signature that you told it was used. Like, It wouldn't restrict the keys at all. So there is another command line option here, the enabled key data, where you're able to provide a list of like your registered keys that it's supposed to use. And like you can disable it actually retrieving other keys or using like a same doc key or whatever. Or you can tell you want to use same doc, but you probably don't want to do that with SAML. But yeah, it's just the lack of our problem basically in how they're calling the program and how they're using the program. And I would also put some fault here on XML sec for not making it clear. Like the API, the interface is kind of just a bad interface in my opinion. Some might disagree on that, but this does feel kind of like some issues we've talked about in the past where it's just like, it's a bad API that's easy to misuse. That feels like the case here. Feels like if you're providing the key, you probably want that key to be used. And like when you don't want to use is when you want to specify something else. But yeah, because of that, somebody could just sign their own SAML assertions, include the key that they use to sign it in the file itself, and it'll gladly just accept that own file. Unfortunately, this also is a tool that hasn't been updated, I think, in quite a while, so I don't think it's going to get fixed. I think the only fix is really using or no, I guess this thing does say there was a release in 2024, so maybe I'm wrong there. I was seeing something like 9 year. Oh,
Well,
right.
the
So
security lab
it's
post outright says that it's marked as archived and not maintained.
go-saml. The library
Yeah.
itself is what's archived and not maintained. Right. So yeah, that I got a little bit confused there. Yeah, XML sec still used, but this repository here, you can see like a lot of these things are 7 to 9 years ago, so kind of old code. Nonetheless, the bug itself is kind of fun. Like I do like that idea of just let them sign their own assertions. Like whatever, we don't care about that. But really, this does, I feel, come down to just a bad interface, and you kind of got to know the gotchas to use it.
Yet another example of crypto isn't inherently secure. It depends on how it's being used. And
Yeah,
in this
that too.
case, it's, yeah, you know. So yeah, that's pretty much all there is on that one. It's a fairly straightforward bypass, even though SAML is a somewhat complicated area.
When you get to SAML, it is pretty annoying, but yeah, you don't need to understand much of SAML to get this one.
All right, so getting into a bit of research, we have a post that kind of touches back on the trick that was used in the machine learning attack post we covered, actually. And that's exploiting CSP wildcards for Google domains. So just kind of talking about some tricks you can use to get around CSPs, especially if they have allow listings set up for Google, because Google has a lot of powerful things that you can use to get around it. So there's the one that was mentioned before with like the Google user content. I believe that's mentioned in here as well.
No,
But
it's
there's also
not.
Oh, it's not? Oh, sorry. I might have
No,
confused it
this,
with the Google
yes.
API's
So this one
allow.
is at least a bit more restrictive, and they're using the example kind of CSP of just allowing any Google subdomain or any Google API subdomain, which the Google user content, most random websites if they're going to like allow some scripts from Google probably aren't aiming for Google user content. Maybe have like a specific service on Google user content they're using, like where they're hosting their own server or something, but probably aren't going to allow that one. That one does feel a little bit Google specific. This one is, though, if they do allow the start.google and start.google APIs, one, they call it the Firebase storage, is like the easy option. And like, Firebase storage of Google API is a very easy option, very clear that you're going to be able to get something there because, Firebase storage is basically whatever you want to put into Firebase. You're able to get content there very easily. But I thought I at least wanted to call out this other kind of bypass they have because apparently there is a library being used throughout Google such that multiple APIs they seem to they only show one case here, but it seems like this may exist throughout multiple APIs because they just mentioned that there's this broken JSON-P library that is widely used across Google estate, which you can leverage. And basically, it's just as JSON-P, it takes a callback parameter, and the idea of the callback is like you would have, or the idea of JSON-P really quickly is you would have a response that returns JSON, but rather than only returning JSON, it'll actually kind of return a JavaScript function call containing that JSON as the data. And that way, just a remote website can include like source script equals that path with that callback function that you want called. they can include that page, and when that page is loaded, they'll just get a function call of it. That's the idea, but you can include an alert call here. They're just doing a open bracket alert, open bracket, yeah, and then like your excess and close brackets at the end. So they're using brackets to kind of contain it, get a actual like JavaScript function call out of it. So you could use that yourself as like a source to include more or less arbitrary JavaScript within a Google. This is a google.com subdomain. Just some, because I've definitely seen websites using like allow listing, especially startup Google APIs. I've seen that on websites, so it's just one of those things to kind of be aware of as a gadget you could use. Probably should eventually get fixed, I imagine, but at the same time, it's widely used, may have some kind of issues with actually trying to fix that.
Kind of got that legacy code debt problem. Yeah.
Yeah, like knowing who all is using it to find like to fix it everywhere and all of that. Like there are some challenges, but nonetheless, for now, seems like it is available. It's just a trick you can use. Like that's really all there is to it. Just a CSP bypass. Normally, I wouldn't consider that too worth covering, except for the fact that like some of these Google URLs are actually commonly allowed within CSPs. So yeah, I figured it was worth it for that.
All right. So we do have one shout out this week, and it is a paper that was submitted to NDSS, ReqsMiner, Automated Discovery of CDN Forwarding Request Inconsistencies and DOS Attacks with Grammar-Based Fuzzing.
Yeah, so this post, I was kind of disappointed by it. Like the fuzzing, it's nothing new. They're fuzzing using a grammar-based fuzzer on HTTP. Nothing really novel there. They're looking, when I read this, looking for inconsistencies. I was hoping for like request smuggling style desyncs. Not even really going for that. They're going for something that is a little bit more interesting, although maybe also limited. They're going for denial of service attacks, so specifically like amplification attacks. If you're not familiar with that, it's like distributed, reflected denial of service attack stuff where an attacker would send a request to some other service. That service would respond, and that response could be directed at like some target, and ideally that response will be larger in bytes than your actual request that went into it. Classic example, UDP packet of like a DNS request. You can make a request for a text record, and the text record can be like so big. I think the amplification on DNS is like 50x or whatever. So like you send a 50 byte, or you send a 1 byte and 50 bytes are generated that go towards your target. And that works with UDP because you could just spoof the IP very easily as long as you're kind of on the core like internet, and your ISP isn't going to strip the spoofed packet being like, hey, I don't own this packet. Like that's definitely fake. As long as that's not happening, like UDP is easy to spoof. This is interesting seeing it done kind of in the HTTP aspect, where what they're looking for are small HTTP requests that can go in to like some CDN in this case, but just some sort of reverse proxy that's going to communicate them with the backend, but it generates a much larger request over to the backend server. So I thought that was at least a interesting sort of attack to go for, just looking for that difference in the size of the request, like size of the request coming in versus size of the request that's actually made. And they claim to have like a nearly 2 million, factor of nearly 2 million, or generally up to 2,000. So like very large amount of packets, but there are some caveats with that. Like they didn't have the denial of service functionality of like Cloudflare, I think, enabled and stuff. So there are some questions on the practicality of this. It is something that would be generally easier to discover and detect, and all of that. But I thought it was an interesting idea to abuse that sort of setup. So I at least wanted to call it out. Most bug bounty programs aren't going to let you report denial of services, so probably can't use it there. But I did think it was novel, and I liked it. I like the idea at least, but definitely some questions when it comes to the practicality of it.
And with that said, that's all the topics that we have for this week for the Bounty episode. So, as always, thanks goes out to everyone who tuned in. If you want to join the community, feel free to join the Discord and Twitter. Links for those are in the description. And we'll see you next week.